Water property. Table of contents. Cohesion, adhesion, moderate temperature, ice, solvent, and finally, let's review. In our previous video, we learned that oxygen is negatively charged and hydrogens are positively charged. This symbol was partially, meaning oxygen is partially negative and hydrogen is partially positive. We also learned that these were called bonds, meaning they connect hydrogen and oxygen. Cohesion. It is a polar covalent bond, meaning different electronegativity bonds. We learned that this is a different force of pulling. It really loves water, which means it is hydrophilic. And there are four hydrogen bonds, H bonding for short. It has a surface tension, meaning same molecules attract, which is also known as cohesion, from those four H bondings, and water molecules gather. Now here are the original water molecules, and then these water molecules around them say, "Oh, I want to get in. Can I?" And then the original ones say, "Yeah, sure, come in." Then they all gather, and these are called cohesion. Now, there are two examples of cohesion. One is a small water molecule in river or lakes. Here's water, and here's also water. But would the water be likely to spread out like this, or this stay packed inside this? The answer is the second one. Why? Because in our previous slide, we learned that water has a high surface tension, which is why they want to gather instead of spreading out like this. That's why water becomes in its original state instead of spreading out. The second example is the water strider. There's water, and here's also water. Then how would the water strider walk on the water? Wouldn't it sink? No, because the water strider's legs are hydrophobic. Have you ever heard of phobia? Well, its definition is being scared of something. So phobic means being scared, and hydro is just water. So the water strider's legs are really afraid of water. That's why they tend to move fast because they don't want to be inside the water. Capillary action is adhesion and cohesion working together. Okay, I understand cohesion, but what is adhesion? Adhesion is molecule attraction of different substances, and it's a upward curve on surface of water and makes plants move water from root to stem to leaves. Why? Because water molecules attach to the sides of vessels. Vessels is just carrying water. Now there are water molecules, and first they stick to each other by cohesion, and then they all also stick. But this water molecule stays to the xylem wall, just to the plant wall, saying, "Oh, I want to be with you. Like, I want to be attracted to you." And then the wall says, "Yeah, sure, come in." This is adhesion because water and cell wall, I mean the plant wall, is a different substance. That's why there's adhesion happening. But this water also needs to have a cohesion with another water molecule. Therefore, this repeats, and then finally in the tree, the water reaches from the bottom to top, not from top to bottom in the direction of gravity. Moderate temperature. Water has a really high boiling temperatures, meaning it doesn't evaporate well. If there's no H bonds, then water will boil at a much low temperature. Why? Because they don't need energy splitting H bonds for H2O molecules to evaporate. There's water molecule, just a normal one, and then they have like a strong H bonds. But what if these disappear? Then it would be just three molecules. And let's say they needed about 10 energy to divide this. But for this, you don't need any energy because they're already divided. But water is usually in this state, and that's why water is liquid. And it helps life on Earth because of H bonds in water. When you go in the ocean, there's sometimes like a really strong sunlight, especially in summer. Then you might wonder, wouldn't the water all evaporate? And we can see the sand below it. The answer is no, because water has a high boiling temperature, so it don't evaporate. That's why the marine ecosystem is able to survive because the water keeps temperatures and they don't evaporate. It has high specific heat and water really don't like to change in temperatures, meaning they want to be in stable state, not in like this state. And water absorb more heat to high temperatures. In cells, biological process makes more heat, of course, because they have to act and move around every time. And when water absorbs heat, it adjusts cell temperatures, so that if a cell becomes extremely high in temperatures, the water will make it low, and vice versa. Ice density is less than water density. We know that density is mass over volume, and ice usually have a big volume, unlike water which has a small volume. That's because in ice, and it usually becomes like this. The hydrogen bonds are very widely spread, unlike water which have high capacity and they want to stick to each other. That's why the volume increased and then the density decreased. First, if you think of ice, it is solid, and water is liquid. If you don't consider ice or water and then just think of solid and liquid, like for example, if you put a pebble inside the water, then would it float or would it sink? Of course it would sink because pebble has a higher density than water. But have you ever seen ice sinking in the water? Never, right? The reason for this is because of this, meaning as the volume increased and mass is the same for both of them, the density automatically decreases. That's how the icebergs in Antarctica are able to float on water, because the density of water is greater than ice density. Water is a great solvent, and it makes up about 70% of a cell. But if there's no metabolic processes in cells, then no molecules have chemical reactions dissolved in water, and then no molecules would make new substances. So here's a water, And we learned that H is negative, oxygen is positive. Then what would this H attract? Positive, right? Because negative attract positive. And O would attract negative because of the same principle. That's how H H2O, meaning water, usually becomes a solvent for almost all of the charged things. But if there's a material that has zero charge, meaning being neutral, then water cannot be a solvent because water is partially charged, but this becomes neutral. Now let's review. What are the differences between cohesion and adhesion? Well, cohesion is attraction of same molecules, and adhesion is attraction of different molecules. Think co as co-working, meaning same, and ad D for different. Why does water have high boiling temperature? That's because of hydrogen bonds. And how does tree get water from the ground? By capillary action, meaning adhesion and cohesion work together so that water can move from the ground to the tree. We learned about adhesion and cohesion. Adhesion was different and cohesion was the same molecules being connected. We also learned about capillary action, an example of a tree, cohesion, and then adhesion into the tree. Also, there was boiling temperature. We learned that water has a really high boiling temperature because the H bonds were strong, and this was why the marine ecosystem worked well. It also had high specific heat, and this was energy needed to increase 1 degree Celsius per gram. And as water is very closely connected, they needed really, really high heat to take apart from them. Ice density was less than water because the volume of the ice was big and water had a really small volume inside it. And that was how the Antarctica's ice floats on the water. Water was a great solvent because it had charges on both of them. Now, the important things that you must remember are hydrogen bonds, which we kept saying from our last video, and moderate temperature. These two are really, really important.